This video is about indicating in the head. They call it tramming the head in industry. What it means to tram the head is you're basically aligning the squareness of the head to the table. The table is always flat and square. When they build the machine, they set the table up to be square. The head is actually adjustable. You can adjust the head left to right or front to back. The A-axis is the head tipping towards you or away from you. The B-axis is if you tip the head left to right. So what I'm going to demonstrate here now is to show how to adjust the head in those directions and then how to check the head squareness to the table. For this, you'll need a 3/4 inch wrench, either a back plunger indicator or a test indicator. So this indicator is a very precise instrument. If you look at the face of the indicator, all the different graduations, each line is worth a half of a thousandths. So remember, a thousandths is in the third decimal place, 0.001. So each division on here shows you half of that. An indicator holder, and probably a collet. What I need for this operation is a 5/16 collet. And that goes on there, then this will go up in your machine. So like I mentioned before, there's a groove on that collet, and that has to line up with the key inside the machine. So you put that in the machine, and you push in. That tightens up the tool. Put your indicator inside the indicator holder, and tighten the screw. So the first thing you want to do every time you run a machine is make sure this head is square. We'll put the machine in the neutral for two reasons. It's easier to turn, and for safety, in case the machine would accidentally start, you don't have your hand on there while it's running. So shift it into neutral for safety. We need to position the indicator centered on the table, so I have to move it on the y-axis. I'm going to have to raise up the table, and you want the indicator to be just above the table. You don't want to quite touch it yet. What I'm checking for is to make sure the indicator reaches the table on both edges of the table. I want to be able to line it up on the y-axis. So every day when you come up to the machine, just check it to make sure it is square. So what I'm going to do is use very light needle pressure here. I'm only going to give it about 5/1000ths of pressure on that needle. That needle, if you give it too much pressure when you go over these grooves, you'll actually break the needle off on the indicator. So use a very light pressure on that needle. Now what we're looking for here is no deviation greater than 0.02 of an inch. That's 0.002. So if we start out with 0, we just want to check it all the way around. We're looking for no deviations greater than 0.02. So right now as I walk up to this machine, it's within tolerance. For this demonstration though, I want to show you how to square up the head. So this you should do every day. That's the minimum. At least check the table. Make sure the head is square to the table. I'm actually going to make the head out of square now, so you can see that it's out of square. These 4 bolts are what clamps the head tight. If I loosen up all 4 of these bolts, you can see the head is starting to move already. On the side here, there's actually the adjusting screw. As I turn that screw, that will move the head back towards square. So you see how the head moves? That is in the y-axis direction. On the side of this machine, there are 3 more bolts. If I loosen up these 3 bolts, I can also tip the head towards me or away from me. Back here now on top of the machine is where that adjustment happens. So I can actually tip the head back or forward. So let's talk about squaring up this head. Right now you can probably visually see it's out of square. If I was to check this table right now, I'd bring the indicator up close and not quite touch it. And what I'm going to be looking for here now is how much airspace there is underneath this needle. So if I raise the table, I'm not quite touching. Over here it's touching by quite a, well, it's not even touching. You can actually see an airspace underneath that needle. I can slide my rule under there. If I check it in the back, it's even further away. If I check it over here on the right-hand side, it's also further away. So the closest point of contact right now is right here in the front. So what that means to me is that my head is tipped down. So to get started here, on the side of the machine there's actually a little angle gauge that tells you what angle you're at. So I'm just going to start out by getting it close to 0. In both directions. I'm going to rotate this one closer to 0 as well. The next step you want to do is just make sure that these nuts are finger tight. You don't want them to be loose, you don't want them to be too tight. If they're too tight, you can't adjust it. If they're too loose, the head is actually becoming separated from the machine. So you want to make sure that they're at least touching so all the airspace is gone. The same thing on the side. You want to make sure that it's tight enough that the airspace is gone. So once you get it close to 0 and you have everything just so it's contacting finger tight, we're going to check it one more time with the indicator and see where we're at. I'm not quite touching the table. Over here, once again, I got a pretty good airspace under the needle, probably a 1/16 of an inch. The same thing in the back and on this side. Now it's up to you. My preference is to do the front and back first. I like to adjust it along the Y direction. It's also known as adjusting the A axis. So I'm going to bring it up just until it touches. That's 0 on the front side. As I rotate it around to the back, I notice there's still an airspace underneath that needle. So what that means is that indicator is actually spinning in this kind of a direction where the front of the indicator is always down. Because the indicator is touching the table here and away from the table back here. So that means the head is still tilted down a little bit. So if I know there's that much airspace in the back, I can actually adjust the head to create the same amount of airspace in the front. So I'm going to bring it to 0 and I'm going to do one more reading. I'm going to check it again. So now in the back it's not touching because as you're raising the head on the machine, the pivot point is in the back here. So as you raise the head, it's kind of like your wrist, if your wrist was a pivot point. As you raise the head, the whole head is coming up. And as it's coming up, it's becoming perpendicular to the table. So because I zeroed it in the back and then I raised it, it's actually not touching in the back right now. So I'm going to zero in the back again. Just raise the table until you get 0 on the indicator. I'm going to rotate the indicator to the front of the table and take a reading again. Now it says I'm off about 6 thousandths. Some students like to think of it this way. If I'm off 6 thousandths, my indicator reading is about 6 inches wide. I'm off about 1/1000th per inch. If you look at where the indicator is now and then look at the pivot point is actually back here. So if the pivot point is more like 12 inches away, and you're taking a 6-inch reading, that's a value of almost 2 to 1. So if I'm off 6 thousandths in 6 inches, I'll be off 12 thousandths in 12 inches. So you can use that to kind of take an educated guess on where you're at. So I'm actually going to raise the table now until the indicator reads about 10 thousandths. Then I'm going to raise the head up to 0 again. And that should get me very close. So now I'm 0 in the front. And I'm 0 in the back. So if you think about the error in the front to back direction or in the A axis, if you think about the error over the span of your indicator, project it out to your pivot point and think of it as taper per inch, you will become very quick at indicating in these heads. So now I know I'm close this way, but I still have more error left to right or in the B axis. So over here it says I'm positive 3 thousandths, and on the other side I'm negative 2 thousandths. So now here, these are the bolts that hold it tight. The adjuster is back here, and your pivot point, if you want to think of it, is actually in the center of these bolts. So as you rotate the head in this direction, whatever you gain on this side, you're going to lose on the other side. So this one here, the pivot point's right in the center, so it's kind of easy to do this one. So right now, if I'm reading a -2 here and a +2 there, that means my head is sitting in this direction. Negative meaning further from the table, positive is closer to the table. And I want to adjust the head to be straight. So I put the wrench on the adjuster and I'm going to adjust it about 2 thousandths. Once you get close, you want to snug these up a little bit more. When you tighten these down, you want to tighten them evenly. Do a little bit on this one, a little bit on that one, a little bit here, a little bit there. Now side to side, I'm within 1/1000th of an inch. Let's just re-zero this in the front. It's easier to keep track of it when it's a 0. So by moving the table, I can re-zero the indicator. I'm going to go to the back side now and see where I am in the back. I'm 0 in the back. Yeah, I'm within about 1/1000th of an inch. Here I'm -1 and over here I'm 0. So this head is within tolerance of 2 thousandths. So what you want to do now is tighten up all the bolts. Make sure you have them snugged up pretty good. These bolts are what holds the head square while you're doing your machining operations, so make sure they're tight. So after you do a final tightening, just check the head one more time all the way around. You're looking for readings less than 2 thousandths. And I have it within 1/1000th all the way around. So just keep in mind when you're doing this, this head does move in 2 different directions at one time. So just look at it in one direction at a time. Get it close on your zeros first. Bring your indicator close to the table without touching. And just swing it around and check for that airspace all the way around. When you're adjusting along the x-axis, just keep in mind that whatever you adjust from this side, you'll gain from this side because the head rotates in the center here. When you're adjusting it in the other direction, just keep in mind that your pivot point is outside the table. So if you take an indicator reading on the table of a known dimension, like here I was swinging about a 6-inch circle, my pivot point was 12 inches away from the tip of my indicator, so I can actually estimate how much to move the head. That's what you need to do to make this go quickly. Chances are this head's not going to be out of square every day, so I do ask, all you do is check the head. Make sure the head is square. It shouldn't move unless something happened to the machine. Somebody either abused the machine or they were taking too heavy of a cut and it made the head go out of adjustment. Typically these heads are square. If you ever find a head that is out of square, just let your instructor know, and if you want to see this demonstration one-on-one, just ask for your instructor. It's a pretty simple concept, but it's very important that you check this. If this head is not square, any holes you drill or any features that you mill will not be perpendicular to the machine surfaces. So it's very important to at least check this every day and verify that it's within a couple thousandths of an inch on the distance of the table.